Mechanism of benzoin oxidation to benzil. This experiment is about oxidation of benzoin to benzil. Benzoin is going to be oxidized to benzil. The alcohol in benzoin is going to be oxidized to a ketone. For every oxidation, there is a corresponding reduction. In this experiment, benzoin is the reducing agent. It's undergoing oxidation, and the other reactant is cupric acetate, copper 2+. It's going to undergo reduction. First, the ketone in benzoin is going to donate an electron to copper 2+. Copper 2+ is now reduced to copper +1. Benzoin will now form a carbocation ion in the carbonyl carbon and then a free radical on the oxygen. It donated 1 electron to copper 2+. The acetate will now grab the H on the alpha carbon, forming acetic acid and also a double bond, carbon to carbon double bond in this structure. This structure is an enol. You have an alcohol in this carbon and a double bond on this carbon. It also has a free radical on the oxygen. There is a resonance structure shown below in which this free radical will now form a double bond on this carbon, forming a ketone, and then one of the bond in the double bond, carbon to carbon double bond, will form a free radical on this carbon, which was formerly the enol. Then this free radical, or the unpaired electron, will now be donated to copper 2+ again, cupric acetate, forming copper +1, and then this carbon, free radical carbon, becomes a carbocation ion. In the presence of acetate, it's going to grab this H on the alcohol, forming another double bond, forming a ketone, and therefore you now have the benzil, which has, in this case, 2 ketones after oxidation of benzoin. In this experiment, benzoin is oxidized to benzil in the presence of the oxidizing agent cupric acetate, copper 2+. It is reduced to copper +1, and we also put ammonium nitrate, which acts as an oxidizing agent, oxidizing copper +1 back to copper 2+. Ammonium nitrate is reduced to N2 gas. It evaporates. So the middle part here is called copper recycling because copper 2+ oxidizing benzoin to benzil, it becomes copper +1 and is oxidized back to copper 2+ in the presence of ammonium nitrate. Experimental part is shown in this page. We are now doing step 1, and I'm going to weigh the reactants for the reaction. In the macro kit, I'm going to take out a 50 ml round bottom flask, RBF, and then this is the reaction container, or this is the reaction flask. And I'm going to set it in a cork. We are now by the balance. I'm going to weigh ammonium nitrate. So ammonium nitrate is going to be 0.1 gram, and then I'm going to use a weighing paper. So I folded the weighing paper, and then I'm gonna put it inside the balance. So write down the weight of ammonium nitrate. The weight of ammonium nitrate is 0.101 grams. And then I'm gonna take out the weighing paper with the ammonium nitrate, and I'm gonna put it in the RBF. Then I'm gonna weigh the other one, which is the benzoin. So the other reactant is benzoin. This is the starting organic molecule. So again, I'm using a weighing paper. So I kind of fold it so that when I put it inside, I can easily pick it up. Okay, and then again 0. Okay, and now I'm gonna weigh the benzoin. The benzoin weight is 0.25 grams. So this is fluffy. So the weight is 0.250 grams of benzoin. So write that down, please. And then I'm going to take it out, and then I'm going to now put it inside the RBF. Okay, and then close the sliding door and then 0 the balance. So we're done weighing. So this is now the 50 ml RBF with ammonium nitrate and benzoin. I'm now going to add a stir bar inside, and then I'm going to add cupric acetate. So I'm going to add cupric acetate in 80% acetic acid. The concentration is 0.015 molar cupric acetate. So I'm going to add 5 ml of the cupric acetate into the RBF. So 5 ml total. And now I'm going to clamp it. So when you have a ground glass joint, make sure that the joints are clean, and you can use a chem wipe to wipe the joints, so that when you put the other joint, which is the condenser, it will not get stuck. So you clean the ground glass joint by using a chem wipe, so that it doesn't get stuck when you put together the condenser and the RBF. So I'm now going to clamp this RBF in here. So I have a sand bath or a thermal well without a sand, and then it's connected to the transformer. I'm gonna set it to 120 volts, and then I'm gonna set it to 50. This transformer is plugged to the outlet, and then I also have a stir plate, and this is also plugged to the outlet. So the thermal well, no sand, is plugged to the transformer and then transformer to the outlet. So now I'm going to put this down. So it's going to be sitting on the thermowell or the sandless bath, and then this is a stir plate. So I have the sand bath without the sand plugged to the transformer, and then I set it to 50, and then this is plugged to the outlet, and then I also have a stir plate. This is also plugged to the outlet. So I'm now stirring it. So the stir bar will stir it, and then once I put the condenser, I am going to turn this on to 120 volts. So in the macro kit, we have a condenser. There are two condensers. Either one you can use, but I'm going to use this one in here. So this is a condenser. So we will use this when we do a reflux. So I have two rubber tubings, one attached to the water. Okay, so I'm going to attach this tube from the water to the bottom of the condenser. And then, so the technique, because this is dry and this is rubber tubing, and then this is glass, I would like to moisten it with water. So I moisten it with water so it's not too dry and it's wet, then I can easily put it in. Okay, and then so this other tubing, again the same. Okay, so now we are going to put it on top. Like so. So I can push it a little bit more. You can actually put it inside just a second. I have the setup actually under the bench hood. So when it's refluxing, because this has an acid, so it can go to the exhaust. So I'm not smelling the acetic acid. So I put it under the bench hood, the condenser. Okay, so any vapor that's gonna come out can go to the exhaust. So we have a bench hood in here, so the vapor is gonna go under this and then goes out into the exhaust. So, all right. So this is a condenser, and I have the water supply goes to the bottom. So I'm gonna put water. So I'm holding the outlet, which is the top, and then I'm gonna have the water on. So slowly. So now I have the water, I have it connected to the bottom. So the rubber tubing at the bottom goes to the bottom in here, and then the other, you can see the water coming out in here. So the water, that's the water outlet, water inlet at the bottom, water inlet going up. So the pressure is pushing the water up and it goes out in the outlet. Now I have it to the drain in here. So this is continuously on, the water in, water out. So the purpose of the reflux is that when we are heating the reaction mixture, the vapor goes up and then it's not going to be dry. So when the vapor goes up, because we're heating it up, the vapor will be cooled by the condenser, and then it's cooling it here, so the vapor becomes a liquid again. So liquid goes to vapor. Once it touches this portion of the condenser, which is cold, it's now going to be converted back to liquid. So again, evaporation, condensation, evaporation, condensation, that's the reflux. So you are not drying your solution because you have a condenser. So that's the purpose of the condenser. Take note that this is not closed, this is actually open. So the condenser here is open. So it's open over here. Okay? So it's not enclosed. Otherwise, the vapor is not going to escape. It's gonna want to pop out. So there's still an outlet in here because that's open. Okay? Now this is a coolant. Condenser is a coolant. So we are now ready to start the reflux. So we are going to reflux for about 30 to 45 minutes, but we are going to time it when I see the vapor coming up and condensing. So I will see it dripping in here. So the heat is going to be provided by the thermowell or by the sand bath. And again, what controls the heat is the transformer. So I set it to 50 and it should reflux. If it's not refluxing and if it's very slow, I'm going to adjust the transformer. But for now, we'll observe if 50 is enough for it to reflux. So I'm now going to turn it on. Okay, so I set the transformer to 50 and then 120 volts. So after I started heating, it's now 10 minutes. So you can see that the liquid is evaporating. You have a simultaneous evaporation, condensation. So when it goes up in here, it goes down back into the reaction flask. So the color changed from, the color of the copper was aquamarine. So it's like blue-green kind of solution. And now because the copper is an oxidizing agent, it's now turning color. So now it's colorless or very light yellow coloration in the solution. And then again, this is open on top. So the top of the condenser is open. It's open in here. And then I actually have it under the bench hood. And then the water is still on during reflux. So we'll monitor the reaction for about another 20 minutes or so. And then we want to see the color changing more to light green. So now after 40 minutes of refluxing, the color of the solution turned green. And then you can see that there is a simultaneous evaporation and then condensation happening, and that's refluxing. So you can see it going down, and then it's being cooled by the water going inside. So this is the water inlet, and then the water coming out in here. So this is a condenser. It has a water jacket. So again, the vapor, when the liquid is evaporating, it's condensing in this portion, and then it will go back to the reaction flask. So you have going up and down, up, down. So the oxidizing agent, which is copper +2, is reduced to copper +1, and it is being reoxidized back from copper +1 to copper 2+ by ammonium nitrate. Ammonium nitrate eventually becomes N2 gas, which is going to be evaporating out of the condenser. So you can actually see some kind of a gas up here. And so still the vapor going down, going up, and going down. So the color changed from aquamarine blue to a light yellow, and now it turned to green after 40 minutes of refluxing. So I'm now ready to turn it off. So I'm going to turn off the transformer to 0 and then turn off and I still have the condenser with the water in, water out, and then I'm now going to raise this up slightly to cool it. So I'm just going to raise this up so it's hot. So the boiling point of acetic acid actually is high, and so the 50 setting was enough for it to reflux. So we let this cool, and then we're gonna add water on top. So I stopped the reflux, and we reflux it for 40 minutes, and the temperature of the reflux was the boiling point of acetic acid, which is 118 degrees C. So at that temperature, the solvent evaporates and then condenses. So it's the boiling point. So the reflux was at the boiling point of acetic acid. Otherwise, if it's below that boiling point, it will not evaporate and then it will not condense. So the benzoin, our reactant, was oxidized by the copper +2, and then the copper +2 is reduced to copper +1 and then reoxidized back by the ammonium nitrate. So we know that something happened because there was a color change of the oxidizing agent, which is the copper. So now I let it cool for about 10 minutes. It's now just a little bit warm to my touch. And now I'm going to add ice water, about 25 ml of ice water. So I have it water in here, and then I'm going to measure about 25 ml, and then I'm going to pour this on top. So I'm going to take this out. So I'm now going to pour the 25 ml ice water on top of the condenser. So on top of the condenser, I will pour this ice water. So it's not precipitating at the bottom. So I pour everything, and now I'm gonna chill it now in the ice water. So I'm just gonna lower it. So I'm gonna take this out now. I don't need it. And then I'm going to, so I'm now going to chill it in ice water. And I'm just gonna add, so I'm just going to add more ice. And then chill it. So that's our reaction mixture, and I will now have the water off. Okay. This is the weight of the filter paper. We are going to do vacuum filtration, so the weight is 0.210 grams. So the weight is 0.210 grams. So write that down, please. So the sample was chilled for about 15 minutes, and now I'm ready to vacuum filter the solid. So in this, this is the filter flask. I have it clamped, and then I have the paper, the pre-weighed filter paper inside, and then I'm now going to have the water aspirator on. And then I will moisten the paper so that it's flat to the bottom. And now I'm going to filter the sample. So I can put a little bit of ice water in this. So it's cold and I might have to refilter that. Okay, so okay. So some of the solid actually precipitate went through the filter flask, so I'm refiltering. So that's one way you can recover most of your sample. Just do another filtration on the same filter paper. And then I also scrape using the spatula so I can recover most of the sample stuck at the bottom of the RBF. So it looks like the filtrate is clear. It's very light green in color. It got diluted, the green color. And I think I got most of the sample out already. And then now, so the sample, so we're gonna take out the stir bar later on. So we're gonna let this dry for a week for the next lab period, and then we are going to do the analysis next time. So I'm gonna take out rubber tubing and then off, and then this is now our sample. So that's our sample, ready to be dried for next time. So I took out the magnetic stir bar, and then we are going to weigh now the filter paper and then with the sample. This is now the sample after a week of drying, and we are now going to weigh the filter paper with the product. So inside the balance, I have the weighing boat, and I already zeroed it. And then I'm going to take it out, and then I will now put the sample So I got everything out, and this is really so this is the filter paper with the product that we have last time. And now I'm gonna put it back into the balance, and the weight is going to be the weight of the filter paper and the product. The weight of the BENZIL product is inside, and it's with the filter paper. The total weight is 0.424 grams. Again, the total weight of the filter paper plus the BENZIL product that we synthesized from last time is 0.424 grams. So after I weighed the sample in that filter paper and in the weighing boat, I took out the sample and I put it in a screw cap vial to preserve the integrity of the sample. And I labeled this as BENZIL product. And this will now be our sample for the next step, which is the HPLC. We will also do an IR of the BENZIL product in the starting compound benzoin.